Hey everyone, welcome to my stream. So tonight I was thinking about what to work on and I wrote down a couple things. I think I'm going to do a little bit of cleanup. I need some, I have some shift register code I wrote in the VIA a couple weeks ago that I wanted to clean up, put into its own class. Gotta find the name of the chip. I have this hacky input code that I wrote here right directly into the VIA, just grabbing the state of the keyboard and hard coding values of the keyboard to inputs that we want. I'd like to do like a proper abstraction for that, and yeah, so that it's more platform, cross-platform. Because despite the fact that SDL is supported on many platforms, I don't really like littering the code with the emulator with dependencies directly on SDL. I kind of like to keep that separate, which is why I have this SDL engine file here, which is pretty much the only file that really has anything to do with SDL except for this input hack that I did in the VIA. And the idea there is that this engine drives the emulator by calling into certain functions that the emulator implements. And say we were to port this to a system that doesn't support SDL, then it should be fairly non-trivial. Fairly trivial. One of the other things that my emulator is depending on right now is OpenGL. That also is something I'm, not sure about, like whether or not. Actually, it doesn't directly depend on it. So that's so far I think I've maintained an indirect dependency on it. Yeah. So that's good, right? So like if we go into main, there's this concept of an engine client. Here it is. It's very simple, and all we know so far is that there's this thing called a display that the emulator uses, and right now it could just clear and draw lines through it. And then there's this iEngine client interface thing, and right now the SDL engine expects you to register a client, and so I think ultimately what would happen here is these would move into some kind of generic header file, and probably SDL engine would be like type def to engine or something, and so then different ports could implement their own engine and type def it. And that's it. And then all the code would just rely on these kind of abstractions. And one of the abstractions I'm going to be adding here is this like joystick abstraction. Because like this display is really like a Vectrex display. So the idea is like what do we want to expose to the emulator as a display. So that's what we have here. And I'm going to do the same thing with the joystick. Kind of like, what do we want from a joystick is to be able to read the analog values, to read the button values, and that's pretty much it, really. So then so the challenge there is just figuring out how to pass that down into our systems in a clean way. Because right now the VIA here, the only public interface is, apart from the init, is this update function, which we call to tell it to update for a certain given number of cycles. And now I have to think about how do I pass down the input layer here, this input abstraction, so that the VIA can query the joysticks to know, what's pressed and all that stuff. So, hey BD, how's it going? Thanks for joining. So I'm gotta think through some of that stuff. So it's just kind of a cleanup. To be honest, I'm a bit tired, so I don't want to embark on some, big thing. One of the big things would be like, for example, improving the rendering. Currently what I do is, as I wrote here, this VIA chip outputs lines which only get cleared once per game frame. So like at 50 Hertz. And this is totally wrong. And what we really want is something like, to really emulate this vector display, which is really just a CRT with phosphors that get excited when the beam goes across it. And we need to be emulating the fact that they are excited at certain amount, like the phosphors or the pixels get activated at certain times with a certain intensity as well. So that's the kind of brightness thing that I'm totally ignoring right now. And like a screen, what I need to emulate is the fact that those phosphors eventually fade to black. I had actually tried something like maybe a couple months ago when I was working on this. I don't even remember exactly what happened. I was trying to render the lines into the back buffer, or into the OpenGL frame buffer, and not clear it, and then kind of draw this like black quad over it with transparency. And all I remember is that it looked awful. I just remember it like flickering, and it didn't quite look right, which kind of surprised me, because or at least now it surprised me. I think at the time I may have figured out why it wasn't working properly, because I feel like drawing this black quad, oh yes, I think I remember what it was. I think it had to do with maybe I'm wrong, but the alpha that I use has to be modulated by the amount of delta time, like the frame time that has elapsed, so that we have a constant fade to black in terms of time. So maybe I didn't do that. I'm not sure. I have to like watch my old stream and see if that's the case. But anyways, that's the kind of thing I don't think I'm going to work on tonight, because like I said, I'm a bit tired. Just want to like kind of just get the code back into a shape, because right now there's a few hacks here and there. So yeah, I'm just going to work on that today. So like for instance, this to do here, move to vector 2. I'll just move this to vector 2. So let's do that. Alright, so that should build. So by the way, one of the things I've been doing for the past couple of weeks, I assume if you're watching the stream you're probably interested in C++. CPPCon is an event that happened just like a couple of weeks ago. CPPCon 2017. So if you don't know what this is, it's a conference that's it's the largest C++ conference in the world. I think they had some like over 1,100 people attending this year, and yeah, and what's really awesome about it is that pretty much every talk that was given is on YouTube. And I've been watching a whole bunch of these over the past couple of weeks. Some really great stuff, like all the big names in C++, all these, people who work on the standard, or people who've written books for C++, like a lot of people who are just well known in the industry. They were there. And so here you can see, like, if I take the playlists, so they have like right now they've uploaded 73 of the main talks. They've got one of the lightning talks for CPCon. So you click on this and you've got this huge like playlist of talk after talk after talk, and this is just going to keep going, because they had some like 6 or 7 tracks for like 5 days, which is really awesome. So yeah, I watched a few that I thought were really great. One that was really out there and kind of is this one here from Herb Sutter. So Herb Sutter is this guy who he works at Microsoft now. He's basically I think he is the chair of the C++ standards committee. Really smart guy, always gives super good talks. Looks like this. And this talk here is about this idea of generating, of modifying the language in order to be able to generate classes. That is different from templates. It's right, rather than doing the whole kind of template metaprogramming thing, you have instead a language feature that allows you to how can I say, kind of get into where the compiler is at and tell it, hey, look over this class, and a bit with there's some reflection in there. So let's say I want to iterate over all the member functions of the class and make sure that they're all const or something like that. So kind of giving you facilities to do that type of thing. So really, really good talk. It's not the kind of feature we'll see in C++ soon, maybe in 10 years or something, but it's kind of interesting to see where they're headed, or at least where I think they're headed, because we never know what happens. But people seemed to really like this talk, so yeah, that was a good one. And one that I really like too is this one from Matt Godbolt, because he talks about his awesome tool, Compiler Explorer. So again, if you're a C++ person, or actually even if you're a Rust person, because I think he added Rust support. Let's see here, C++, D, Rust, Go, ISPC, Haskell, and Swift. So yeah, actually lots of languages in there. It initially was for C++ and it was with GCC, but what it does is it allows you to write code, and you can pick which compiler you want, for which there are quite a number of them. You can add your compiler options and all that, and what's really awesome is that it basically compiles it and shows you the disassembled code here, the assembly code, and matches it up with colors. Super interesting to see what kind of code gets generated for which kind of, to see what kind of assembly gets generated. You can do diffs between different assembly outputs of different compilers, different versions. You can mess around with compiler flags to see how it affects the generation of the code. I use it even just to see will this code compile on a different compiler, because it's just so easy to pick different ones here. So if you haven't seen this, I totally recommend it. And the guy who wrote this, his name is Matt Godbolt. He gave a talk here about how unbolting the compiler's lid. So explains how it works, what he did, what were the motivations behind it. So another good talk. And there's a whole bunch, so I'm not going to spend too much time talking about it now, because I think I already have. But if you're into that, I definitely recommend you check it out. Actually, you know what? I'll be right back. I'm just going to go get my coffee. I think it's ready. So I'll just be right back in a few seconds. All right. Okay. So yeah, ABD says neato. I actually went to CPPCon, not this year, but last year for 2016. I begged at work to have them send me, and they did, which was awesome, and I loved it. So definitely, not only recommend watching the videos, but if you can go, that's even cooler. All right, so what's next here? So I did that. Move vector 2 into its own header. Okay. I wonder if there's any other low-hanging fruit. You know what? I did do this. It's good to check your to-dos every once in a while. See which ones you actually forgot in the code. That's why you can't trust your comments, right? Okay, I don't see anything that would be low-hanging fruit right now. So let's go do our shift register. So it just shouldn't be too hard. Most of the shift register stuff is put together down here. It's just shift cycles left plus this like function for update shift. So ABDCW asks, question, would you recommend the Ergo Pro? Because I was looking into buying the DOS keyboard and the Ergo Pro, but don't know which is a better option. Well, you know, obviously there's a huge difference, right? The DOS is a single piece keyboard, whereas the Ergo Pro is split. And the only reason really for getting a split is because you have RSI problems or don't want to have RSI problems. So for me, I do have RSI problems. Like I typed for a long time on regular keyboards and then started having pain in my wrists. And so then at the time I switched to the Microsoft Ergonomic 4000. This one here. Very popular keyboard. So yeah, I was using this one for quite a while, and actually I really like this keyboard. I love the kind of contoured shape that it had. It was great. The only thing is that it was rubber dome. So ABD says, yeah, I had the Microsoft Ergo 4000, but it's really mushy. Yeah, so totally, it is. And you know what? It got mushier over time. Because I had one of the earlier models, the earlier versions, like back in like, I want to say 2005 or something. And at the time, I think the build quality was a bit better. They were still rubber domes, but there are differences in rubber dome qualities, right? So at the time it was not so bad, but then, you know, that keyboard, after a few years of usage, I needed to replace it just because it got like, you know, so mushy after a while. So I bought a new one, and immediately, first of all, it was $20 less than the last time I had bought it, and I could see there was a difference in the build quality. They had cheaped out on a few things. I remember even removing the space bar, and noticing that they had only a single pivot, like, or a single I don't know what you call it there, slot, whereas the old one had two. So like the space bar would teeter a bit more, which was really annoying. So anyway, after that I decided, you know what, let me see if I can find a split keyboard that's somewhat similar but has mechanical keys, and the Ergo Pro is what I found. I think since then there might be a few others out there that have come out. So I like this guy. I like this keyboard. It uses switches that are similar to Apple's switch from their old keyboards. What do they call them again? So they're not cherries. It's actually a switch that the company Matthias that makes this keyboard, they bought the rights to make them. And honestly, I really like these switches. They're very comfortable, nice actuation point, all that I would want in a switch. So I'm glad with that. My only complaint, there's only really one, is this keyboard lets you tent the keyboard like this, or it lets you have a negative tilt, but you can't have both. It's one or the other. And actually the Ergonomic 4000 from Microsoft has both in its design. So that's a picture of the negative tilt there, right? And by virtue of the fact that it's kind of contoured, it has this kind of tenting going on built in, right? But in this one, it's either tenting or negative, not both, right? So if you do the negative tilt, you get the more comfortable, hands going downwards, but you don't, you're still kind of turning in your wrists. Tenting keeps your wrists at a more natural position, but they're not as leaning towards the back as I would like. So if I could, and ideally my keyboard would be something like this, So I think I could do it if I like raise the front. I'd pretty much have what I wanted, but I need to put like some kind of piece of wood or something in the front, and I don't really feel like doing that. So I opted for the tenting because that's the one that's the least problematic for me. And it's pretty good, and like you can adjust how far away you want to type. When I first started using it, I was using it really far, but actually over time I found that I was not as accurate, and maybe it's just me, but I needed them to be a little bit closer to get the accuracy that I was used to. So again, that could just be me. So should you get it? It depends how important it is for you to have a split keyboard. If you're more into like if you don't need a split, actually that's the thing, right? If you don't need a split keyboard, if your wrists are totally fine and you're fine with like a one piece, you have so many more options out there, which is, it's kind of, sometimes I wish I could use a regular keyboard and not feel the pain that I often feel after just a few like after an hour of typing, because I'd love to get one of those fancy, the DAS is nice, but there's so many other ones. But that's life. In the end, I need a keyboard to type, so. And this is my livelihood, so right? So I gotta take care of my wrists. So hopefully that helps you. Alright, so this shift register is going to contain its value along with the number of shift cycles left. And the reason I want to do this is not just for cleanliness, but because there are things I haven't implemented yet in this shift register for it to be completely accurate. I have some notes here, stuff that I read from the vid documentation, or VID. So there's a whole bunch of stuff here that I'm not quite doing, and so I need this abstraction to cleanly implement this stuff. Very, very much like I did for the timers. It's so nice how VS 2017 will allow you to create, it'll just create the CPP file for you when you do that control dot that I just did, and tell it, add an implementation. It'll actually create the CPP file in the same place as the header. It'll include the header for you and then put in the implementation, which is pretty sweet. All these things that just save the rote creation of files and all that. And I know a lot of IDEs do that, but it took a while for Visual Studio to do it, so very happy that it's there. Oh yeah, so this affects the blank. That's right. So we need to connect this with the blank, which is really how this chip is supposed to be wired. We're supposed to make sure to check the, how does this work again? Okay, what I'll do for now, it's not quite right, but it'll get me there, partway there, is no, not there. We'll just pass in the blank for now, and then we'll worry about connecting it properly after. Okay, let's include the shift register. that doesn't quite work. Alright, so maybe I do need to not do this hack. Since it can control the CB2 blank line, the shift modes can be set and described here each time the shift outputs. So yeah. It can be used to control the blank. Every time a shift outputs a bit, that bit is placed into the CB2 line. Shifting out a 0 enables blank. So this is similar to how the timer has this PB7 signal, right? So let me see, how did I... Right. So I can do something similar. The CB2 line. So maybe if I do it this way, we'll ask the shift register if the CB2 is active, and this is going to be what we set instead of blank. See here, I'm going to move this into the CPP file just by doing this. Although it stupidly adds this inline specifier because the function was inlined in the header, but it makes no sense to do that in the CPP file, right? In fact, it can cause problems. Okay, so now here, and then there's this whole thing about when do we do it. Okay, let's try this. This is not exactly what I had before because I would only set blank every, whenever I would hit one of these conditions. But I think that the whole idea behind it was that it would keep its last value until it changed, right? So it should be okay to do this every time. And I believe there is this concept of shift register being active or not, in which case, similar to how we're checking some flag on the timer, we will need to check if the shift register is in an active state, and if so, then we drive the blank. To do check some flag on the shift register to know whether it's active. And I'll say here shift. cb2 line drives blank. I wonder if it'd be more clear to kind of like, because right now I'm doing update, 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 and then I'm doing some stuff with the outputs. But maybe I should keep like the timer relative stuff next to timer 1 and this next to blank. I don't know. Sorry, next to the shift register. Anyway, I think for now it's okay. Let's see if this works. So far, so good. All right, that looks good. Okay, so it doesn't look like I broke anything so far. Oh. You know what? I got this when I was testing the game last week. This is not really related to my change though. We're just getting for some reason there's a read on the memory bus on an address that's not mapped. It goes into the so-called unmapped memory device, and for some reason the game is trying to read at a really. Yeah. Yeah, that's right. 8,000, which in the memory map. Does this make sense? Yeah, I'm not even using my CPU implementation right now. So that actually might be, this may just be because it could be a bug in the Vectrex CPU. Let me try with mine just to see. It happens when I shoot that. In fact, you know what? In the second wave there, we saw this, the shape of the mine that's got like this, it looks like a bit like a ninja star with like a dot in the middle, and in fact that shouldn't be there in the second round. It's supposed to be a kind of like kind of cross-shaped thing, star thing. So there's something else going on there. I'll just try with my CPU to see if it's happening. I did make quite a bit of changes last time I worked on this on stream there, and I had made a bunch of changes to refactoring the CPU, and I may have gotten something wrong in there. But I'm interested to see if the same behavior occurs with my CPU. Oh, actually I'm saying I did refactoring the CPU, but this bug appeared without my CPU, so that doesn't make sense. So maybe it is a bug in Vectrex. Okay, so here we go. We'll try a second wave here. See, that's it. This guy here shouldn't be here. So I'm pretty sure now as soon as I fire him... Oh no. Okay, well this time it didn't crash, which is good. Didn't get that weird assertion. But I'm pretty sure that guy's not supposed to be there. Unless, maybe I'm just misremembering it. I might just be misremembering it. So it's possible that that's what we saw before has to do with the other CPU implementation. Maybe there's a bug there. Because it was kind of weird. We had this memory address that was totally out of range, right? So there's probably some bug there. Whew. Okay. It's so hard to play with the keyboard. It's crazy. I can't wait to implement a proper joystick support there, or I mean gamepad support, and try and play this with my gamepad, which I should be able to do pretty easily. Once I refactor my input code, that's what I'll do. All right, I'm satisfied with this, and I will add here implement gamepad support. Once we do the hacky input code abstraction. Okay, so let's go back to here and let's clean up all the shift register stuff that I commented out, because I'm fairly happy with this. Shift register mode shift. What is this about? Shift register mode mask. Yeah, so that's the thing. There's some shift register mode stuff that I'm not quite respecting in my shift register. Like, expected to only support shift out under 02. Yeah. So there's these different modes about the shift register that I will maybe implement if there are games that need it. But since it only supports one so far in most games in the Vectrex that I can see, I'm not going to bother with that stuff. See, it's here, CB2 to blank. This is what sets up CB2 to drive blank, right? And what I just exposed was whether CB2 was active. And I don't even know if that's really the right way to say it. It's basically there's an output from the shift register that connects to CB2. So probably it's not the right wording, but good enough for now. We'll worry about that later. Why is it not finding this code? Oh, because I already cleaned it up. Okay. Oh, here. So that's gone. And I just wanted to write, I think there was something about the shift register chip here somewhere. Yeah, so this is the thing about CB2 blank, that if it's set to 110, blank is enabled. If it's set to 111, then translated to Vectrex analog, blank is disabled, although blank is usually controlled by the shift register. And I think in my case I actually assert, right, that this is the case. Yeah. No, that's not what I'm looking at. Bits 5 to 7 in the wire control register. Okay, that's the peripheral control. It's this one here. CB2 shift is blank enabled. So I think I'm doing this wrong. Where I'm assuming is blank enabled has to do with setting the M blank flag, which is completely not correct. Okay, so yeah, this is not right. Okay, so what I'll do is let me commit what I have, and then we'll worry about fixing this after as a separate commit. Okay, so the bias shift register mainly responsible for shifting out top. It's top. What can I say? For driving the drawing of vector of line patterns. So yeah, it's mainly responsible for driving the drawing of line patterns. It can be loaded with an 8-bit value, that 8-bit mask that represents the pattern to be drawn. And although it's called a shift register, it actually rotates its values. So the pattern will repeat. Okay. And I just have to say, I don't know if you caught that, but basically I just hit Control S and then it formatted my comment into multiple lines, respecting my limit of up to 100 characters, which you can see this is actually at 100 here. And it's really cool because if I add some stuff here, it'll readjust and reflow the comment. And this is a feature of client format, which I totally love and think everyone should use. But anyway. So white space is no longer a problem of mine. Okay, so we added these two files, and we have modifications into the via. Oh, so some stuff in the header file that I forgot. I'll leave that one. And actually, while I'm at it, I wanted to, how do I do this? Change signature. No. Change, how do I do this? Oh, Control RR. New name, just update. Beautiful. I love when refactoring actually works. And I wanted to rename this guy. Cute. Always look over your changes. Okay. So I'll say factored out shift register code into its own class. So let's fix this thing here about what it means, the CB2 blank. Yeah, there was something about it up here. Alright, so shift mode is controlled by the first mode is disable. The next three modes are shift in modes, which is not used by Vectrex. Shift mode is controlled. Which is which these 3 bits. It's interesting how he says that the shift in modes are not used by Vectrex. So I think what he's saying, usually shift mode is always 110, shift out under control of system clock, which is what I'm asserting. But I'm wondering why he says, where is this first mode is disable? Where is that? Because there are only 3 bits here, right? Anyway. Timer 1 modes, okay, this I already handle. Shift out, okay. VIA controls, register controls the control lines of VIA. Control lines are CA1, CA2, CB1, CB2. All control lines act as interrupt inputs or as handshake outputs. For Vectrex analog parts, and for now, the lines CA2, 0, and CB2 blank are most interesting. The CA1 line is connected to the second joystick port. Okay, yeah. CA2 0 responsible bits. Blank 110 low. So blank is enabled, blank is disabled. Although blank is usually controlled by the shift register. The manual appliance to the blank signal with the control register only has any effect if shift is switched to off. Okay, so then the manual appliance. So if I'm reading this right, it's saying that when the shift register is in the off mode, then you can manually toggle on and off the blank signal. Which then means that maybe I had it right. Let me see here. Perif control. CB2 mask, CB2 shift. Okay, I think I understand. So this control register is connected to CB1 and CB2. So in our case, we care about how it's connected to CB2, and it looks like it will drive CB2, which is itself connected to the blank. And what it's saying is that through these bits, by setting it to 110, 111, you can control directly whether blank is enabled, which is what I'm doing here when you write to 0xc. But what he says here is manually modifying the blank signal like we're doing here only works if the shift register is off. So I need to have like an if here. If the shift register is, disabled, then we do this. And conversely, I need to have the if shift register is enabled in this part here where we actually control the blank. After updating the shift register every cycle. Now the question is, how do you turn on or off a shift register? And that, I believe, is back up here when he says the first mode is disable. Let me see. So I think what this means is actually there are two bits here, 2 and 3, that determine what, the shift out, like where the shift register shifts out to, or what controls the shift out. And then this bit here, the 1 that we see, bit 4, is what controls whether or not it's enabled. And it seems like in general it would always remain enabled, but I'm pretty sure I read somewhere about, it's like some ROMs controlling the blank, or actually was it for... What was it again? No, it was, sorry, no, it was not for the font rendering. But I think I saw some code that went ahead and like controlled the blank itself rather than rely on the shift register, which is typically a bad idea, but does give you some control. It might have been in this document, which is a Russian document that I've looked at a few times. And when we translate it, okay, and then I think we can search for shift. No, I don't think it's in here. Seem to be lacking information on this. So either I go with what I think it means, or I just put an assert that it is always enabled and see what happens in the cases where it's disabled. Bit 4. So I already have basically an assertion here that's always checking. So I think we will leave this alone, because if ever there is, if it ever is disabled, I mean, I can't find the information I'm looking for how it is set to enable this or disabled. Okay, I have an idea. What we'll do is like this. We have set value and a CB2 active. Update. So what I'll do is I'll put a bool enabled. And for now, we'll always return true. And I'll put a little comment to that effect. For now, always return true, as it seems the shift register isn't disabled by games on Vectrex. Also, I'm not sure exactly how to control the enabled state of the shift register. I believe it may be controlled by bit 4 of the Via's auxiliary register, is it? Auxiliary control register. Okay, so at least now we have some code that we can put around our setting of blank. And in this case, if it's not enabled, we set it. So I mean, this could change something, because right now whenever this guy was being set, the peripheral control, I was also setting blank, and now it won't do anymore. But I think it's going to be fine because the shift register is pretty much always used to control it. Seems to be working fine. All right. Shift register, add concept of enabled state, although it currently is always assumed true or something, enabled. Okay. So we're done with the shift register. Move that into my done stuff. Looking at the time. Let's see. I think about how am I going to do this for the input. So like right now in render, I pass the display. Most likely for update, I would pass in the like input abstraction, probably called input with joysticks in it. And then what do I do with it? You know, do I just keep passing it down? One way I can do it is to, I don't really like doing that, but like tell the Via, here's your input, and then it's kind of stores a reference to it, but it's really not the kind of thing I like to do. Otherwise though, I find myself passing it down, which maybe is what I'll do, and here in the Via update, we would pass it down again. And this guy would be able to use the input when, where. That's the thing too, is that right now I'm not actually reading input in update. I'm doing it lazily here, which is probably not right. And furthermore, right now it would be in the VIA, but actually the input really is connected to the PSG, which is the sound chip. So ultimately, these values need not be read here, but be read from the PSG. I guess one way I could implement this is I could pass it in and then I could cache the state of the input, assuming it's copyable, which I don't really like either. Trying to think, why did I make the reading of the joystick analog and the joystick buttons happen lazily like this, like on demand, and why didn't I just set state based on it? I guess because I wanted to simulate what would really happen in hardware, because it's all analog devices, and so when you read a bit, you're actually reading the value from the hardware. So maybe what we could do as a first step, just a really simple first step, is something like let's cache the results of these in the update and return them from those functions and see what happens. See if it still works correctly. Oh no, but this one here depends on the mux selection. So that's probably why I did it this way. Oh, okay, that's it. I would need to store all four. Okay. Sorry, I thought I heard something. All right. Joy Mux 1x. Trying to think if I want to do it this way. Okay, let me just hack something together for now, and then I'll see about this. I'm going to use a stood array because if I access out of bounds, I will know. Okay, so let's see if this works. What's this? Right. So I'm curious to see now. There will be technically more lag in terms of reading input, but I don't think it'll be a problem because we update the VIA so often, but we'll see. Okay, so far so good. Okay, this is good because this allows me to do what I was saying. Pass in the input state down through the update functions. Which is really the way I want to do this. Oh, so there was that same error we had earlier, but this time we know we're using my CPU. So we're doing a load. And there it is, read from unmapped range at address 8000. So there it is. It is really the unmapped range. I have this unmapped memory device to catch these exact problems. Unmapped memory device here. So somehow there was a read that was being made to this address. Strange because I never got this before, so that's why I suspect that there may be an issue. See, now it's reading from 8001 and it's probably going to go now to 8002. So I must be stuck in some kind of loop. Okay, where are we? Let's see. So if we're in F, that means we're in the BIOS. So we're in the middle of drawing. Apparently. 414. Maybe a clear. And then here, load A, comma X. Load into A. What's an X? Comma X, right? That's an indexed mode. Yeah, and there's X with a value that's in there. So the X register points to the vector list. Get pattern bytes. So the question is, how did 8000 hex get into X? So since this happens with both CPUs, my implementation and the Vectrex, we can pretty much rule out that the CPU is the problem here. Most likely, the code, it's a bug in the VIA, where we are reading, it's trying to read some value from the VIA registers and not getting what it expects, and so it just keeps going, something like that. Or maybe the timer, which is again a VIA thing, and so maybe then it ends up somehow X at some point keeps growing till it reaches 8,000, something weird like that. It's strange because I haven't really touched a VIA in such a long time, and I haven't had this problem. I've been able to play. Let me see something. Oh, that's interesting. So we're running the default version. And it's true that I haven't been playing the default version. Let me see if I run the one that we built, the one that's like a newer version. This one. Oh, did I put in the wrong place? I did. Command arguments, yeah. Be interesting to see if this version doesn't cause that, and it's possible that it was fixed, this weird out of bounds access. Maybe it actually is in the original version. I don't know. These are the fixes that went in. Anyway, input seems totally responsive as expected, so that's good. Although, I think I'm noticing that when I fire many bullets, oh, look at that. This is the enemy that I was expecting. So it acts differently when I play this version versus the built-in version of Mindstorm. So I wasn't completely crazy. There's something with the built-in version that's not quite working for me. Interesting. But I mean, the built-in version should work. In all likelihood, there's a bug somewhere in my emulator, because this should not behave this way. I'm super curious now to try like another emulator to see what happens. Okay, anyways, at least I know I didn't introduce anything. I think it's just because I've always been testing with this version of Mindstorm, which has been working. And when and now I started testing by accident with the built-in version, and that's where this bug exists. And I think it's probably been there for a while, I just didn't know. So, okay, I'm not gonna focus on that right now. So here I'll say via cache input state or in update rather than read values lazily. Don't know if I want to do it this way. Trying to think what's actually useful here. I have kind of like two strategies here. I can make this input here like a nice high level abstraction, which I then need to convert to a low level abstraction for the via, or I can leave it in a low level state, knowing that it's going to be consumed by the via and in that state, you know? So like basically what I have here, having let's say an 8-bit mask for the 8 buttons, one from button joystick 0, one from joystick 1, and having like the 4 different values for the analog state for XY of joystick 0 and or joystick 1 and XY of joystick 2 would be more convenient, but at the same time it's not a friendly high level thing. Then maybe I can just expose that through some high level functions to set those. Yeah, that's the right thing to do. Actually, you know what? I'll be right back. Just gonna go to washroom. So I'll be right back. Okay. Read button state mask, something like that. So basically this will be the public interface that will be consumed by the VIA for now. So it's just going to match pretty much what we have. Be like analog state mask. And here we'll say int and now we'll have the interface for setting state, which pretty much will be used by the engine. Which then, in that case, kind of sucks that it's public, but unless I do some kind of like friend type thing, which I'm not a fan of, so I don't really care. So let's just do this. So we'll do like set button, and then what you'll do is you'll pass the like joystick index, and the which button you want to set. Trying to remember what the joystick looks like. Right, 1, 2, 3, 4. Button. I'll just say button index. And I'll have set analog axis joystick index. I'll do set analog axis X with the index and the value. And I'll just do set analog axis Y. Okay. For this one, we'll be doing joy button state. So first we'll start with okay, so it's how much the shift left by. Oh, yeah, I kind of need to know if I'm enabling it or not, right? Yeah, there we go. Whoa. Okay. My keyboard just went wonky there. Okay, so for the mask, going to be 1 shift left by the button index. Because basically if you look here, like for joystick 0, this bit here is set for, this means button 1, button 2, button 3, button 4, and then for the next joystick it's just shifted left by 4. So what we want to do is we want to build a mask where we take 1 and shift it left by the button index, okay? And then we shift this left by joystick index times 4. So that's kind of gross, but let's put this in a variable. So then we say mask and whether or not it's enabled. There we go. Okay, so this here, what's wrong here? Right, of course. So, yeah. Joystick index. If it's 0, then it's 0, and if it's 1, it's going to be 4. So we shift the whole thing left by 4 bits. And for which button it is, we just take 1 and shift left by that. Is that correct? I think so. I guess I could technically just add these two together. And then do it this way. Right? Yes. The joystick index needs to be less than 2. Button index needs to be less than 4. I should probably make these unsigned. We'll see. So I might have to cast these. Okay, so now let's do the analog. Okay, so here, so just want to say, go in here. Don't even remember how I stored this again. Alright, X, Y for the first one. Yeah. Not super happy with this, but one step at a time. Okay, so let's say we have this input class, right? So now update will get a const ref actually to the input. So by making a const ref, it means that in fact the emulator can't even use these functions. So that's perfect, right? So let's propagate this. So we'll go into main here, where now this override is no longer valid because we added this guy. We're going to pass that into our debugger. So yeah, I need to include. Okay, so at this point, now that I'm passing a type all the way down, I'm going to want to move these guys out of SDL engine and make a file like iEngine client or engine client. That's what I'm going to do, and all this will go in there. I might want to break this down a bit further eventually, but for now this should be okay. Actually, what do I have up here? Right. Array. So SDL engine. This should build, except we now must pass an input here. I think I'm not setting my state here. I think I cannot initialize an array here, if I recall. Is that true? Or maybe I'm wrong. So input, and we'll pass input here. Alright, so now we come back to debugger. And that guy gets passed down to the via here. in our... Okay, so for now we'll include engine client, which is a bit weird, but we're doing it for input, right? So let's see if this builds at least. Okay, so some's got some errors here. What's the problem? Okay, unreferenced formal parameter. iEngine client base class undefined. Oh yes, I need to include it in here. Declaration of input hides function parameter. What's that? Oh, that's funny. And that's what you get for calling a class such a generic name. Okay, I'll rename this string here. I'll call it input command or something. Yeah, it even matches my last command here, so that's nice. Okay. So now I'm just left with the unreferenced formal parameter, which is great. Because here, the idea would be, rather than call read joystick inputs, we do button state mask or something. Okay, so this should run, but now I have no input anymore. Meaning I just need to hook up the keyboard presses to set those input values. So see, like, now I can't play anymore. Okay. So what I want is to get rid of these, but by moving the general gist of what's going on here into the SDL engine. So let's do that this way. So I'll call here update input. And I will write this function somewhere up here. Set analog axis. Let's do this. What are we doing here? We're grabbing the keyboard state. So right now I'm still going to keep the hack of hard coding what we want, but that's fine. And then we'll be able to change this afterwards. Make it allow the user to map their own keys and use a gamepad, and everything's being controlled by the SDL engine where it should be. So joystick index 0, button index 0. No, actually it's button index 4. No, 0 is state of a not equal to 0. So this becomes 1, 2, and 3. And this becomes S, D, and F. So that's button state. And then for analog, for axis X, for joystick 0, we are looking at this code right here. Okay. So actually, I could totally do this and get rid of that input object up here. Just always return a brand new one. And then we pass it in. So let's see if this actually works. And it's not working. Let me just go into debug here, and what we'll do because here I was setting it when the scan code was equal to 0. Why was I doing that? It was like some kind of reverse logic, right? Oh yeah, that's right. So what we actually want is we want the buttons, that's it. Internally we want these to be on and then turned off. Bits on if not pressed. That's it. So in which case I will want to do something a little different here. I'll say like, maybe that makes it more obvious. Well, if you want to enable it, we're going to set the bit to the opposite of that. Okay, let's try like this. Okay, we're in debug, that's why it's slower. Like, this looks different, and we're like running at about 100. Oh wow. Okay, let's switch back. Much too slow. I really need to fix that. Okay, hopefully this will work. Yeah. So there is something, and I think this was the reason why I had the like lazy reading of the input, is that I think what happens in the game is that you see how it looks like when I fire one bullet, many bullets get fired, like a ton of bullets. I think that's incorrect. And I can easily check if that's the case by just resurrecting quickly the hack that I have here. Where was it? Like if we just ignore the cached state and read the buttons here, does it change the way how many bullets I fire? Let's see. Oh, maybe not. It looks like it does exactly the same thing. Okay, so that's good, and I won't worry about that. So it looks like I've got what I want, so I can get rid of this whole hack here now. Okay, let's bring this back. The only thing I don't like is this kind of button state mask, analog state mask garbage. But I'll be honest, I don't care right now. I'll just leave it alone. And if it bothers me too much, we'll change it. Okay. So this changed. This changed, yes. Yeah. Everything there except for this part. We added this file. Debugger got this. Okay, I don't want all of this, but I do want up to, okay, most of the file. All right, so here I'll say replace input hack in via, or I'll say implement proper input abstraction and remove. Oh, and actually, you know what? I forgot something. I forgot to remove these two, SDL events and SDL keyboard. Which, do I have them up here? Interestingly enough, I don't. But I didn't seem to need them. Oh, probably because SDL.h includes them. But see, now it's nice because I don't have that crap at the top here. So let's make sure we pick that up. Okay, so implement proper input abstraction and remove hack. Or just, oh yeah, that's good enough. And I'll say here, remove SDL keyboard reading hack from via .cpp. So I'm looking at the time, it's getting kind of late. I would like very much to get my Xbox controller working. I don't know if I'll be able to do that now. Let me see, where is it? Where did I put my controller? Trying to remember where I put my... Oh, there it is. I fell behind the computer. So, like, ideally... So ideally, I have 4 buttons here, you know, and I've got my analog axis. So through using SDL, I should be able to relatively easily read these values. So let's see if we can find some code to help with that. SDL read Xbox 360 controller. Okay, so it looks like we need to add controller support. Added, removed, down, up, controller axis motion. Button axis events embed SDL controller button event and SDL controller axis event respectively. Makes sense. Do not run on application startup for already connected devices. In that case, you will want to iterate over the joysticks and attempt to add each as a controller. Removal is pretty straightforward. So I mean, I do want to do this kind of, you know, correctly and support the adding and removal. But for now, I would love to just kind of hack in. I assume it's connected. I grab it and I just read values. Controller button and controller axis. So there's basically the event has these C device, C button, and C axis. Okay. So I guess what we'll do is we'll just get these here, controller button up and controller button down events, and see if I even get those. We'll start with that. So we have our little SDL event handle loop somewhere here. So let's do some printing. Axis motion. So it's just something like this. Just to see if I even get values out of SDL for my already connected controller. And it doesn't look like I do. Okay, so Windows sees my controller, so it's not that. Oh yeah, I know exactly what it is. I read it earlier. I need to init this thing with SDL, right? Still no inputs. I don't know. I wonder if, I mean, I'll add these ones, but I don't think these make any difference. But let's try them. If I remove and then add. Oh, interesting. So it detected the device added here, and now if I press buttons, will it work? If I remove, so no breakpoint for removal. I get one for added. Interesting. Interesting and a little bit scary. Well, that's depressing. Okay, let's see if we can find more information. Not on Linux. So maybe it's because I really do need to do... Yeah, I think that's what it is. I am missing this add controller code, whereby, yeah, because he says that when you start the game, it will not call these functions, but you kind of need to do them. Right, yes, some sort of mapping. They do not run. In that case, you'll want to iterate over the joysticks and attempt to add each as a controller. So I guess the idea is an index. Okay. Right. So we'll need some kind of mapping here of controller index to what? Some kind of ID. Joystick instance ID, which looks like to be an int as well. So we'll say G gamepad index to instance ID. Wait a minute, what's the mapping he's talking about? Oh, so it really does keep a mapping to the game controller. So what's the point of getting an instance ID? open a game controller for use. This index, the index passed as an argument refers to the nth game controller in the system. This index is not the value which will identify the controller in future controller events. The joystick's instance ID will be used there instead. Right. SDL joystick ID. Game controller from instance ID. Okay. Seems to me that that's the thing we should be keeping. And then what's this game controller close? Takes a game controller. So we'll go with instance ID, right? And then we'll say SDL get game controller. What is it? Game controller from instance ID. So maybe I shouldn't call it gamepad. Why do I need this? Couldn't I have just gotten the instance ID? Okay, this opens it, gives me a controller. From a controller, surely I can get the instance ID from the game controller. Okay, so you need a joystick to get its instance ID, which is what this is. Game controller get joystick. So it's so strange, this concept of get the underlying joystick object used by a controller. What is a joystick? Versus a controller. I guess I'm missing the anyways, it's okay. Okay, so let's say this is the case. What we'll do now is we'll make sure to call add controller index 0 the first time, just to see if that registers our joystick. interestingly, this time we got the event that it was added. Controller device added. So now, look at that. I actually pressed something, and let's take off all our breakpoints and see what this output looks like. Why am I not getting any printfs? Oh. It's because I'm in buffered mode. Button down, button up, button down. Okay. Cool. There's my axis motion. Alright. Right. Game controller device event data. Type device added, removed, or remapped. Timestamp and which. The joystick device index for the added event. Instance ID for the removed or remapped event. Oh, really? Okay, well that doesn't correspond at all to what was in that sample code. It says that it would be the instance ID here. So technically we wouldn't need this line at all. Okay, I'm getting closer. So let's say controller button down. STL controller button event. Okay, so here we go. So what I'm going to do is I'm going to do this update input here. So this is not quite right anymore because now I'm like basing myself off events. But what I'll do is I'll just put some hacked code in here for now. That says So C button, in terms of which, the joystick instance ID. Let's say right now we'll just make sure it's 0. Actually no. We want to make sure that not quite what I should be doing, but it's okay. So it says the button, and I can use this function, STL controller button. Oh no, okay, it's one of these. Perfect. Let's grab these 4 buttons here. Set button, button index. So I don't know what to do here. 1, 2, 3, 4. And I need to know whether it's down or up, so I guess that's going to be one of these fields. STL controller buttons. State. Pressed or released. Something like that. And now I need to change the order here, so I'm just gonna keep this like this. I'm looking here, I think I'll do X is 1. No, sorry, X is 0, A will be 1, B will be 2, and Y will be 3. So this, if this works, I should be setting the I should be able to press keyboard keys and then also press gamepad keys to override those if this actually compiles. What's the problem? It's initialized but not referenced. That is true, because I don't care. Okay, let's see if the joystick works, or at least if the button works. Oh, something happened. Okay, so it's not quite working. I think I need to... What is it? What is it that I have to do? Oh, right, I need to handle down and up. Right, that makes sense. Yeah, so I guess I don't really care to check if it's pressed here, right? Technically speaking, this should just be true because we're pressing it down. Okay, so actually what we're going to do here is we're going to put these two together. And we're going to check which one it is in here rather than check the button state. Or can I check the button state now? No, that's it. That doesn't make... yeah, maybe I can. Let's see. There's basically redundant information, right? Like, button down means the state should have changed to pressed. Unless pressed is more about detecting edges. Ah, maybe that's what it is. So like it tells you it was just pressed, perhaps. Perhaps. Which I don't really care about right now. Yeah, still not much better. Okay, so let's do this differently. Let's say... button down is equal to button down. And what is this garbage here? Wait a minute. Okay. Okay, so it's not working at all the way I think it should work. Button press, %D. %S. Let's go button and we'll say the button is down, we'll say down, otherwise we'll say up. Always easier to debug input stuff with printf. Oh yeah, and I need to why am I not getting buttons here? Okay. Down, up, down, up, down, up, down, up. Oh, I know what's happening. Yeah, okay. So the problem is I do need to keep this input object around for longer than just the one frame, because if I press a button, it needs to remain pressed for multiple frames, because this is an event-based system, right? So if I do update input like this from the keyboard, I need to remember what the values were every frame. Okay. Oh, and actually I can't do it this way because I can't, let's say, hold the keyboard, because that's going to clear values that was set by the joystick. So I really can't have both without doing some funky logic to check whether the keyboard did something. Yeah, so let's just forget about the keyboard for now and just make it in controller driven. That'll make more sense. Okay, this looks like it'll probably behave better. Let's see. Okay, I think I'm setting both movement and firing with the controller for some reason when I press this one button here. So let's see. Button B. Getting close, and it's already midnight. Okay, that's fire. Teleport. For some reason that's fire too, so that's not correct. There's definitely a little bug here. When I press X, can't see anything. Oh, I know what I can do. What's this? All right. I could remain in release and just remove optimizations on some of these functions I'm debugging. Okay, X, when I get pressed here, what does my input state look like? Okay, it's FF. Come in here, and we build our mask. X was mapped to 0, correct. So that wants to set only 1 bit. So let's see here. So that should turn off position 0, which it does. And what about, okay, Y, oops. And Y was mapped to 3, so yeah, 3rd bit should be turned off. And when the button is down, what is it doing? Maybe this is where my bug is. Turns it back on. That's perfectly fine. I mean, I know this logic's right because when I do it with the keyboard, it's perfectly fine. So what is the deal here? Okay, so I pressed B, which really should only be setting this one here. So let's see what's going on. Hey, look at that. The joystick buttons, they did change. How so? It did change. Surprisingly. Oh, jeez. You know, sometimes you just feel like a noob. Forgot my brakes. And it's funny because when I first saw that it was doing multiple press, I thought, oh, maybe I got the switch case wrong. I looked, but didn't look properly. That I forgot my brakes. This is why you don't program when it's midnight and you're tired. Okay, so now let's do analog and we can switch back to release with debug info. So how does analog work? C-axis, game controller axis event. I guess I can be const here. Now what does this look like? So the type tells us the SDL controller axis motion. Game controller axis motion. That's what the type should be. Okay. remember which joystick instance ID, the controller axis. Okay, so there's my enum that I care about. Okay, so we've got our axis. Now let's go back to the value. Okay, so that's the range. We're just going to remap it. What am I missing here? That's it. Okay, so now what I want to do here is actually, I don't care about the right. Something was weird here. Oh, okay. I'll split this out into functions soon enough, but I just want to make sure this works first. Okay, so moment of truth. Let's see if the analog stick does what I was hoping. just to show you. I'm playing here with the controller. Okay, so not quite. Okay, there's just a bug when I get to the end. Okay, I need to fix that. It should be 127. If this works, I'll actually be able to play this game with my controller, which is pretty cool. There we go. Let's see how this feels. Oh, 6 so much better. Oops. So I think A is teleport. Yeah. Oh, this game is way more fun to play with the gamepad. That was close. I'm clearly playing better now that I actually can play with my gamepad. That was interesting, actually. For a moment there, we saw this huge vector get drawn. So definitely there's a bug somewhere related to vector drawing, and this is happening even with this ROM. Very interesting. Okay. Anyway. So, quite happy with how this has turned out. I totally need to clean up this code. So I'm gonna hold off on, well, actually I'll just commit this on a branch and we'll clean this up next time. So I'll say gamepad input work in progress, or just gamepad input. Okay, commit. I'll just put whip. We'll continue this next time. So we push my changes. I'll push master as well. Okay, so I think that's it. So this was a pretty good session. I didn't think I'd actually get gamepad working tonight, but pretty happy to see that. And next time we'll clean all this up, and yeah. So if things go according to plan, I should be resuming my. The next stream will be on Monday. So thanks for hanging out, guys, and yeah, hope to see you next time. Thanks.